I'm CK. Today we've got a kit that I picked up from eBay. It's a motor speed control kit using pulse width modulation. We'll see how they set up a circuit to set up the pulses and put it together, see how much fun it is to use, whether we learn anything from it, and I hope you enjoy the video. The bag, let's open her up. Got a battery box for 3 AA's. Let's take the paper out first and we'll see what goes on. And it is all in Chinese. That's what I thought. It's all in Chinese. No English, no URL or QR code for a build guide, even though maybe if I went to the listing, they may show something. I don't know. I'm not going to bother. I mean, that's a resistor 1K, that's a 104 cap, and so on. So, and the placement numbers, so it'll be easy to put together. And voltage in is 4.5 to 30 volts. Huh, that's interesting. And it's got, chip-wise, it's got a 78L12. I don't know what that is. But over here, what's creating the pulses is what I thought. It's a 555 timer chip. So the variable resistor is going to be here or here. Do they have? Are there two? Oh yeah, there are two. Huh. There's one trimmer, and there's one regular potentiometer type variable resistor that will set up the right capacitor resistor values to vary the output speed of the 555, which is going to trigger this transistor, which is going to flow current or voltage, or however you care to choose that, through the motor. So that looks pretty neat. And we've got a couple of diodes, number of caps, 1, 2, 1K reference resistors probably, and then the variables. The trimmer, I assume this is going to be the trimmer, and the trimmer probably allows us to set a range. So let's see what the parts look like actually. That will be interesting. I'm going to back this camera off a little bit. You all need to tell me whether I'm zoomed in too close or zoomed in too far, or zoomed out too far. So here's the circuit board. It's a good circuit board. All through hole plated. It's higher quality than most circuit boards you get in inexpensive kits. That's what I meant to say. Power comes in here. Maybe power goes out here. I'm going to have to double check that. I think so. We'll find out later. See what we got. Got a nice little DC motor. Tabs look all, they're a little bent, not much, nothing to worry about. A little propeller to put on there for fun. And then we've got 2 wire terminals for input and output, power in and out. We've got this big old beefy heatsink for this 142S. What is that? I'm sorry, I'm looking at this. Yeah, it's TIP 142S to control the flow of power. And we've got our 555 timer, and this is from, I don't know, it's got some goofy kind of logo on it. I don't recognize the logo. It does have a piece of smuts on it. Here's one transistor. Or is this a voltage regulator? I think this T8L12 is a voltage regulator. I will look that up and report back when we get ready to build it. Here's an on-off switch. Here's a big old knob to go on this variable resistor, 50K variable resistor. And there's the trimmer, and the trimmer's just, it's a 103, so it's a 10K. And a couple of 3 electrolytic caps and some 104 decoupling caps. They probably go right near, yeah, they go by the 555 to smooth out the energy, get rid of the induction near it, and all that kind of stuff that you use decoupling caps for, that you can read about better than I can describe. So that's it. That's the parts. Looks pretty simple. Let me get the soldering iron heated up and we'll get this thing going. Oh yeah, and interestingly, just again to show you this is a little better quality than some, they actually included a socket for the 555. They didn't have to. We can solder it directly to the board. In fact, I'm probably gonna solder it directly to the board just so I can keep that socket and throw it in my spare parts. So let me look up this, what was it again? Where is it? It's right here. 78L12. Again, I think it's a 12 volt voltage regulator, but I'm not certain of that. Looking at all datasheetarchive.com. Yeah, positive voltage. It's a voltage regulator. Thought it might be. So we're going to start as we usually do. Again, there's not many parts, so there's not a lot to decide on. We'll just put the, oops, my garbage can's not in the right place because I was recording a demo this morning and I had to move the garbage can, so I have to go get it and put it back immediately to my left, or else there will just be a pile of junk on the floor because it's such a habit for me to toss stuff away real quickly. And there are only 2 resistors, and they're 1Ks, and they're marked as 1K. I'm going to put it on the meter just to see what the tolerance is on it, what it comes out to. 0.980, that's fine. That's dandy tolerances. Tuck that one in. So yeah, resistor time is up. I put it in the wrong. The diode hole is right next to the resistor lead hole. I probably could put them both in the same because they're coupled, but I don't want to do that really. Yeah, no resistor time tonight. And I just said what I was going to do. Oh, we're going to put the 2 diodes on. Our favorites, 4148s. And the board is well marked for polarity on the diodes, which is always a plus. It's actually an area where almost every board I've seen of the hundreds I've done for this channel so far, that most boards, they may not be good on capacitor marking, they may not be good on sometimes even transistors, but they almost always get the markings for diodes well done. I'm going to put the 104s on also. Now, interestingly enough, actually, as I'm looking at this, why did I thought that the board didn't have values on it, but the board has all the values on it, so we don't need to look at the build guide at all. In fact, we may just rampage through this. Okay, so I was just given a compliment. But now, as you can see, the voltage regulator sight does not have good marking as to how it goes. Let me take a look at the schematic. So yeah, I know what that does. I'm looking to see where so that's the input and that's the output. Actually, I'm putting it, I'm being an idiot. That's for the big old MOSFET. This is the voltage regulator. Actually, why is it? Oh, I read it wrong. God, I'm being silly tonight. So you can see the slight angles on the board to show where the curved side of the voltage regulator goes. I'll get that in there. I'm not going to put that big old character on there yet. I'm going to put everything else on the board first. Again, the capacitors are very well marked as to what they are. This is and how they're oriented. This is the 220, right? Yeah, it is. Okay, so that's all I'm going to put on for right now, because it gives us a good little bit of soldering. You want to save up your soldering time, or I do. I like to have at least, generally, like 10 things to solder before I pick up the iron, just so I'm not going back and forth and back and forth. It's just my style. You can solder each one as you put it in if you want. Nothing wrong with that. I do that sometimes on bigger boards. Okay. Now, I'm going to put the trimmer on. And we'll put the two connector blocks on. Pins are a little bent, but that's okay, it helps them stay in. They're a little taller than this cap. That was not good. I hope these are okay. I think they are. Cut another little piece of solder. Get this one nailed down first. Now I'm gonna, like I said, I'm gonna permanently mount the 555 here, because I actually have more spare 555s than I do 8-pin sockets. So I'll just put this guy right on the board. And I have better quality 555s. I mean, I'm not saying these are bad or this is bad. I just don't recognize it. So, but when I buy TI parts, I know what I'm getting into. So the socket I will put in spares. The 555 we'll just leave on here. And now one switch. Again, I'll rest that on my finger while I solder it in place. And it's not flat, it's at an angle. That's That's why I only did one pin, so I can reheat that pin, let it cool, and it's all, no it's not, I didn't flatten it completely. There we go. Now it's all flat and flush to the board. And finally, we're going to do the power transistor. And the way I approach this is I'm going to loosely mount this here and then put it all on so the height of the transistor and the height of the heatsink are the same. And you don't need to do this. I probably shouldn't do that, or I'm not going to use this enough for this to matter, but I did just put some thermal paste on there to make the thermal connection a little bit better. Again, I don't need it for this kit, but I just like to do it as a good habit. Anytime I mount a power transistor to a heatsink, I put just a little bit of thermal paste on it. Now we're going to line it all up. Solder some things. I'm going to solder the heatsink first. The heatsink, of course, is not doing anything electrical, but you solder it so it doesn't go wandering around. I keep looking at my cameras because they cut out after 30 minutes, and I don't know if I've exceeded that yet. Because I'm looking at it and saying I can do this all in one take, so to speak. And now we'll put the potentiometer on. And I know that is not flat on the board either. I felt it give a little bit as I set it down. So same thing, just pick it back up, heat that leg, and it's all good. So there we have it. That went together very quickly, very straightforward. Now, I'm not sure what I'm gonna do some setup here because I want to get a little I want to get the oscilloscope set up because that's what's going to be the fun part of it, and I'm going to solder some wire onto this motor. Why don't I do that? I'll do that on camera because we're here. And I'm going to cut this piece of wire in half. And I just had it laying around on the workbench so I don't have it marked as positive or negative. Actually, why don't we... I'll use this piece of black wire for negative since I have it lying on the bench also. It's a little short, but if I want to use this as a fan later, maybe I'll rewire it. Who knows? It's one side. Make sure this goes through. It does. Okay, good. The other side. And we'll solder that. And now I'm going to get a bench power supply over here because I don't want to use batteries on this. Okay, so we're set up. I've got the motor in a pan of ice. And as you can see, there's a little bit of reflective tape here because I'm going to use my little RPM meter to check that. You'll also notice here I've got the oscilloscope. I stripped some wire going to the motor, so we've got the oscilloscope leads connected there, so we can see that on the scope as we do things. One other thing I didn't do, I put that heatsink on and I didn't finally tighten it down. So we do want to tighten. Why is that not? That screwdriver doesn't fit. Let me get a different screwdriver. We want to tighten that down so it's cooling it way off. Okay, so I'm feeding this 10 volts at a maximum of 2 amps. It's not going to take that, but let's turn it on, and there we go. And you can see it's somewhat interesting. There's the pulse on the screen, and you can see it's a relatively narrow pulse. And you can also see it's got that, after the pulse hits its peak, it's got these loops. I don't know what those loops are for. Maybe it's the capacitor in here discharging along the way. Now what I'm going to do is I'm going to speed it up, and as you can see, the pulses get wider, and you can probably hear that the fan speed is changing. I'm going to take the voltage down a little bit here. I'm going to take it down to 5 volts and see if that smooths anything out. It doesn't really. It smoothed it out a hair. Yeah, we'll just run it at 5 volts. Let me change the vertical scale here a little bit. Okay, so now we're going. And let me try and tilt this up without completely messing everything up so you can see the RPMs. So let me turn this back on. Can you see this? I'm going to back the camera up a little bit more. I'm going to point and aim, and this is going about 5,900 RPM. So we'll change the pulse width, make it much longer. And now that's taking us up to 9,300 RPM. That's pretty neat. So that's the way it works, by not changing the voltage, but by changing how long the voltage is on. Let me set that in roll, see if it works in roll. No, it never works in roll. So a small low speed, small width. So we increase the width. Let me get up here again and see if I can do this. See if I can be coordinated and do it at the same time so you can see it on the... There we go, 1700, 3000 RPM. Now we're going up, up. Pulse got much wider. Take it all the way up to 9300, 10,000, 12,000, 13,000, 16,000 RPM. And let me adjust this a little bit so we can see it. The pulse is very wide now. Back it back off. And take it all the way back down again. Fast, slow. So that's the way a pulse width modulation changes speed. And as you can see, it's a pretty simple circuit as such things go. Now I'm gonna drive it way high on voltage because it says it can go to 30 volts. I think I'm only gonna be able to get it to 20. No. Whoop! Whoa! 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 Magic smoke. Zoom in on the magic smoke. We just toasted some capacitors, taking it up to 25 volts, even though it's, again, the sheet says it's rated for 30, but apparently not. So if you get this kit and are playing with it, don't go to the rated 30 volts, because your capacitors will just fry their little... Actually, it wasn't the capacitor, it was the voltage regulator. Ow! Yeah, it was the voltage regulator burnt up. Well, that's pretty neat. So we had some fun with that. Again, it's a very good kit. I think the circuit schematic is very instructive. Unfortunately, it's all in Chinese, so if you don't read Chinese, you won't get as much out of it. But you can figure it out how it works pretty much from the schematic. And again, read up on your 555 timers. And if you want to have a little additional fun, just turn up to 25 volts and fry your voltage regulator. And don't believe it when it says 4.5 volts to 30 volt. 4.5 volts to 30 volts, because that obviously is a lie. And I hope you enjoyed the video.